Hello everyone, welcome back to AceMaths. Before we start factorizing algebraic expressions, there is one very important foundation skill we must understand clearly. Highest common factor or HCF. Every factorization begins with HCF. So in today's lesson, we will learn how to find HCF with numbers, letters, and powers so that factorization becomes much easier later. Let's begin. First, let's quickly understand what a factor is. A factor is simply a number that divides exactly without leaving a remainder. For example, 3 is a factor of 12 because 12 divided by 3 is exactly 4, and that is why 3 is a factor of 12. Now let's find the HCF of 12 and 18. First, list all the factors of 12 and 18. Now let's first look at the factors of 12. We know that factors of 12 are 1, 2, 3, 4, 6, and 12. Because all these numbers divide 12 exactly. That means they do not leave any remainder when they divide 12. Now let's find the factors of 18. So factors of 18 are 1, 2, 3, 6, 9, and 18. Right? Now we look for the common factors. If we scan both the lists, we can find that here 1, 2, 3, and 6 are common factors. So let me just write them down. We have 1, 2, 3, and 6 as the common factors. And the highest of these is 6, right? So the highest common factor is 6, and that is why the HCF of 12 and 18 is 6. Now let's include algebra. Here we need to find the HCF of 12x and 8x. First we will look at the numbers. So the step 1 should be finding the HCF of 12 and 8, right? So let's list down the factors of 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. All right. And the factors of 8 are 1, 2, 4, and 8. Now let's look for the common factors. So we have 1, 2, and 4. So the common factors are 1, 2, and 4. Now for HCF, we look for the highest common factor. Clearly, the highest common factor is 4, and that is why the HCF of 12 and 8 is 4. Now, let's talk about the second step, and the second step is concerned with the letters. We can see that both of these terms, 12x and 8x, contain an x. Both term contains x. So this x is the common factor. So since both terms contain x, so the HCF of 12x and 8x is 4. That is the result from the step 1, and x, that is the result from the step 2. So 4x is the HCF of 12x and 8x. Now let's solve the next example. We need to find the HCF of 18mn and 30m. First, we need to work on step 1. Step 1 is always concerned with the numbers. So here we have 18 and 30 as the numbers. So let's find the HCF of 18 and 30. To find the HCF, we need to list all the factors of 18 and 30. So let's start with the factors of 18. Factors of 18 are 1, 2, 3, 6, 9, and 18 itself. Now let's write the factors of 30. Factors of 30 are 1, 2, 3, 5, 6, 10, and 30, right? Now let's look for the common factors. Clearly in the list we can see that 1, 2, 3, 6. These are the common factors. Let me write down the common factors first. Common factors are 1, 2, 3, and 6, right? Here we can see that the highest common factor is 6. So clearly the HCF of 18 and 30 will be 6. Now let's talk about the step 2. We know that the step 2 is concerned with the letters. So here we have mn, and in the second term we have m. So we have mn and m. So both the term contains m, right? Here we have m, and here we also have an m. So the HCF here, mn and m, will be m. So now we will combine the results of step 1 and step 2. So finally the HCF of 18mn and 30m is equal to 6. That is the result of step 1, and m, that is the result of step 2. So the HCF is 6m. Remember that you need to include only those letters that appear in every term. Here in this example, we have mn in the first term and m in the second term. If you compare both the terms, you will find m being present in both the terms, and that is why in the final HCF only m will be present. We will have to leave n because n is not present in both the terms. Now let's deal with the powers. Here we need to find the HCF of 36 p squared q and 24 pq squared. So we will start with step 1, and step 1 is about finding the HCF of the numbers. So we need to find the HCF of 36 and 24, right? So let me just write down the factors of 36 first. Factors of 36 will be 1, 2, 3, 4, 6, 9, 12, 18, and 36, right? And the factors of 24 will be 1, 2, 3, 4, 6, 12, and 24. Now, let's locate the common factors. Here, 1 is a common factor, 2, 3, 4, 6, and 12. These are the common factors, right? So let me write the list. So the list of common factors are 1, 2, 3, 4, 6, and 12, right? Now, the highest common factor is 12. That is why the HCF of 36 and 24 is 12. So we are done with the numbers. Now we will take the letters. That is the step 2. Now in the first term we have p squared q, right? And in the second term we have pq squared, and we need to find the HCF of these two terms, right? Now there is a very important rule here that you need to remember. The rule says that whenever we are finding HCF among letters, we always take the smaller power. Now let's implement that rule in the current example that we have. Here in the first term, we have p squared q, and in the second term, we have pq squared. Now let's talk about p first. According to the rule, we need to take the smaller power. Here, p has the power of 2, and here p has the power of 1. So, using the rule, we will take the smaller power, that is p raised to the power of 1. Now, let's deal with q. In the first term, we have q raised to the power of 1, but in the second term, we have q raised to the power of 2. Now, the rule says that we need to take the smaller power. That means we will have to take q raised to the power of 1. Now, p raised to the power of 1, q raised to the power of 1 is simply pq, right? So the HCF is pq. So we have found the HCFs in the first and the second step. Now we need to combine the result. So the HCF of 36 p squared q and 24 pq squared is 12 from the first step, and pq from the second step. So the answer would be 12PQ. Now let's solve a similar example. Here we need to find the HCF of 10x cubed y squared and 15x squared y. Here we need to first find the HCF of the numbers. We have 10 and 15. Let's find the HCF of 10 and 15. First, let me write the factors of 10. The factors of 10 are 1, 2, 5, and 10. Right? Now let's write the factors of 15. Factors of 15 are 1, 3, 5, and 15. Now let me find the common factors. So here 1 and 5 are the common factors, right? So let me write it down. Common factors are 1 and 5. Clearly, the highest common factor is 5. So the HCF, or the highest common factor of 10 and 15, is 5, right? Now let's do the step 2, and step 2 deals with the letters. Here we have x cubed y squared, and in the second term we have x squared y. So we need to find the HCF of x cubed y squared and x squared y. In the previous example, I mentioned a very important rule, that was always take the smaller power when we are finding the HCF that is concerned with letters. So here we have x cubed y squared and x squared y. So let's talk about x first. Here the power of x is 3 and here the power is 2. So according to the rule, I must take the smaller power. So I will take x squared, and for y, here we have y squared, and here we have y raised to the power of 1. So I will have to take the smaller power of y, that is y raised to the power of 1. So this is x squared y, and x squared y is the HCF of x cubed y squared and x squared y. So finally we can write the HCF of 10x cubed y squared and 15x squared y as 5. That is the HCF of 10 and 15 from the step 1, and then x squared y, that is the HCF of the letters from the step 2. So here we have our final answer. Now let's see why HCF matters. Why this is so important. Look at this expression. We have 12x minus 4. Now, can you find the HCF of 12x and 4? Okay, so first let's take the numbers. So we have 12 and we have 4. The factors of 12 are 1, 2, 3, 4, 6, and 12, right? and the factors of 4 are 1, 2, and 4. Now, the common factors are 1, 2, and 4, right? These are the common factors. And clearly, 4 is the highest common factor. So, HCF of 12 and 4 is just 4. Now, let's talk about the letters, right? So, here we have X, and here we do not have any term containing X. So, actually, we have X and X raised to the power 0, right? So, we have X raised to the power 1 and X raised to the power 0. Think of this as 12x raised to the power of 1 and 4x raised to the power of 0. Alright? So now, if I ask you to find the HCF here, and using the rule that we just learned, we need to take the smaller power of the letter. So the smaller power is clearly 0. So x raised to the power 0 is 1, right? So final HCF of 12x and 4 would be 4 times 1, that is just 4, right? Because 4 is the HCF of 12 and 4, and 1 is the HCF of x raised to the power of 1 and x raised to the power of 0. So the final HCF is 4. But I want you to understand this very important thing, that here we had two terms, 12x and 4. Since x was not present in the second term, we can simply drop x from the final answer, because x is no longer a common factor, as the second term does not contain x. Now, let's take the original expression. We had 12x minus 4, right? Our HCF of these two terms were 4, right? So let's factor out 4. If we factor out 4, we will have to write 3x here and minus 1 here. It's because when we multiply 4 with 3x, we get 12x. And when we multiply 4 with negative 1, we get a negative 4. That is 12x minus 4, right? So this process is called factorization. If you look here carefully, you can see that I have broken this 12x minus 4 into two factors. The first factor is 4 and the second factor is 3x minus 1. Again, this process is called factorization, and every factorization always begins by finding the HCF. And that is why in this video we took many examples and we learned how we can find the HCF in different cases. So if you master HCF, factorization becomes straightforward. So today we learned how to find HCF with numbers, letters and powers. In the next lesson, we will use this skill to fully factorize algebraic expressions step by step. Make sure you practice these HCF examples before moving forward. If this video helped Give it a like and subscribe to AceMaths for clear concept first IGCSE lessons. Happy learning, and I will see you in the next class.